All right, so yeah, this one right here, it's out of order. The numerator is out of order, and we're missing a term. Maybe we'll need it, maybe we won't, okay? So this numerator, now let's go and rewrite it in there, right? So let's take that, the 9x cubed is the leading term. It's the highest degree term there. But the negative 44x squared, yeah, that needs to be next. Okay, but in addition to that, just in case we need it, I am going to apply a plus 0x because we're missing that x term there. And then I'm going to do then we got the constant minus 28. Okay, so this is in descending order. Is it true descending order? Yeah, whether you show the 0x or not, by the way. But the denominator is the x minus 5. Okay, so this is long division, and I'm going to take my numerator, which I've written graciously and pretty, and I'm going to divide it with long division by x minus 5. So divide it by x minus 5 here, okay? So at this point, again, we want to get that quotient with some kind of remainder, but again, I got 9x cubed. I am now missing at least 2 x's, x squared, but we're going to need 9 of those, right? So 9x squared times x would be 9x cubed. That's what we're getting rid of, so I'm subtracting it. But then I've got to multiply it by the negative 5 as well. Now the negative 5, multiplying this by a negative is going to, even though we're taking those away, since we're multiplying it by a negative, it's going to make that a plus. So 9x squared times negative, well, just really 9x squared times 5 would be 45 of those x squareds. Okay, so that's, oh, that's going to be one individual x squared. That's actually kind of nice. We did zero out the 9x cubes, though. And then everything else drops, right? So we got the plus 0x. Maybe we're going to need that. Maybe we won't. I think we will, but let's find out. And then, again, we're focusing on just this part of the expression, but x squared, I already have an x. That means I'm missing an x. So I'm just going to, since it's positive down there, I'm going to keep this plus. X times x is an x squared. You can say a 1x squared if you like. That's what I'm taking away. But then I've got the x times negative 5. So again, that would be plus 5x's right there. So that does zero out the x squareds. And then I've got 0x's plus 5x's, which is 5x's. And then the negative 28 drops. I can actually keep working with this one. Yeah, so on this last part right here, we are missing, we got the 5x. So I'm going to multiply that x by 5, positive 5, because it's positive 5x down there. 5 times x would be 5x, but I'm going to take those away. And then 5 times 5 is 25, but it's really 5 times negative 5, so I'm going to have to add those in. Now again, the purpose of that is to get rid of the 5x's there. Negative 28 plus 25 gives us a remainder of negative 3. So again, let's go ahead and write that quotient down with the remainder. We got 9x squared plus x plus 5. And then we have a remainder of negative 3, or if you wanted to, you could write it as 9x squared plus x plus 5. And then just, again, whether you put addition or subtraction here, I mean, it does make a difference. So you could put minus 3 like this over the denominator x, yeah, x minus 5, yep.
Let's do the next one.